So first, I wanted to say thank you very much, everyone, for coming today, this morning. I know yesterday was a fun night, and to me, also want to thank to everyone who actually took the time to talk to others, socialize, share your knowledge. I think that that's very important. One, because you're meeting fun people, interesting people with so many different skills, but at the same time, you're meeting potentially your next opportunity, right? Your job opportunity. So keep that in mind when you talk to others, right? It's very important to start building that network as well. And today we're going to be talking about some of the concepts behind AWS Identity Access Management that are actually abused by threat actors to elevate privileges. And we're going to be sharing some of our research notes and what a defender can do. And at the same time, we're going to share some free resources, right, open source stuff that you can then take home, try to use it in your organization, but at the same time, you can do it at home if you're just simply trying to explore how AWS is from an identity and access management perspective. Now, this is very important because yesterday in the first keynote, one of the main points, I think it was point number 6 of the 11, it was talking about intelligence, right? How you can make intelligence actionable. From a research perspective, that's what we're also trying to do. How can we share our knowledge in a way that others can also use it right away? And how you can even use some of the resources that we're sharing so that you can deploy infrastructure right away, apply all the concepts that we're sharing so that you can get up to speed with all these things that we're trying to do and share. This is part of our multi-cloud research approach because we come from Microsoft, right? But it's also good for us to start investigating some of the relationships between AWS, Azure, GCP, et cetera. Okay, and these slides are going to be, of course, shared through SANS. But if you cannot see some of the content from the back, that's the link. It's going to take you to a GitHub repository where the slides are available. Just download that PDF and then try to keep it handy in case you want to really deep dive into some of those images, because sometimes it's hard to put everything in one page. So just in case, I think that we figure that would be good to do. And of course, thank you to the SANS Summit, because they're giving us a space to share what we love the most, which is our research, and also giving us a space to meet others as well and learn from others. So thank you very much for doing that. And my name is Roberto Rodriguez. I'm a principal threat researcher for the Microsoft Security Research Organization. I love dogs and open source in that order. And if you want to follow or keep track with some of the research that I do, just go to that repository. That's part of the Open Threat Research community. I'm actually the founder of that community. It's a community that encourages collaboration and also development of open source. So everything that I do, even at Microsoft, they allow me to open source a lot of my work. So there is where most of it ends up. And some of it, of course, ends up on the Microsoft and Azure open source GitHub repositories. And the Microsoft Security Research Center also recently did a story, a research spotlight about me. So if you want to learn a little bit more of what I've been doing for the past couple of years, you can go ahead to that link, and that came out with a cool avatar. So I'm pretty happy to see my babies also with me in the avatar, my 2 dogs in there. So that's pretty, right? All right, cool. So I'm going to pass it to Ashwin.
Hey, good morning, everyone. My name is Ashwin Patel. And also welcome and thanks for SANS for providing this opportunity to share our research in this forum. So I also work as a senior security researcher at the Microsoft Security Research team. I do not have a dog, but I have a kid. So same thing. Yeah, this is the one photo that we took it when he was 6 months old. Now he's 18 months and keeps us busy all the time. If you follow along some of the stuff that I've done, there's a GitHub repo that you can check it out.
Oh, and also I want to say thank you. So Ashwin asked me to tag along into this research. So it's been pretty cool also to dive into new technology, like new areas of expertise and, learn some new stuff. So it's pretty cool. And that's something that we encourage a lot to do. Do not just get stuck into one topic in your organization. Try to explore other things that might also allow you to use some of those skills that you already have, trying to do research, applying your methodology in one topic. So we try to also do the same thing with AWS in here. And Ashwin was the one leading the whole thing. So it's pretty cool to be able to finally present some of those things. So
yeah.
Right?
Yeah, really excited to share the stage with Roberto as well. So for the today's talk, the agenda is kind of divided into a few high-level categories. So Robert is going to take us to the whole attack surface terminologies, how it can be applied to the cloud world. Then we'll be the 101 of the IAM to understand what are the different terminologies that involves into IAM. The IAM in the cloud world is rather complex, so it's very essential for defenders to understand what are the different entities and relationships works, so that you can use that for investigations or developing detection purposes. The latter part, we are going to cover a few scenarios. Also, like we are going to take a look at the Jupyter-based framework, which you can take it along and then right from starting deploying the infrastructures, then simulating the attacks, generating the data set, and then also analyzing the data set, then developing detections, and then lastly destroying those resources once you're done. And then all of those stuff is shared via GitHub as a free resource.
And one thing to mention also is that, as Ashwin just said, there's going to be a couple of Jupyter notebooks. And that's kind of the thing that we're bringing besides the research, that it's not new. I mean, all this research has been done also from 2017, 18, right? The past couple of years. A lot of the offensive community has actually taken this topic and shared a lot of open source tools to actually do this type of attacks. But we have not seen resources that would take you through the simulation, but also through the defense side of things, like correlating the data, taking the data out, out of those S3 buckets, or directly, if you want to call it from an API. That's something that we had not seen. So we figured it would be good to reference, of course, all this amazing research, but also add a little bit of what we actually do as well, which is implementing things such as Jupyter Notebooks, which is also another open source tool that you can use that allows you to document your research, keep your input and your output, so you can actually have code that you can run and simplify the whole process to share it with somebody else and allow somebody else to replicate the whole process. So that's also something that we're trying to do in here, besides the research piece, right?
Yeah, that's why the name came from the Defenders Edition.
Exactly.
Yeah, so we'll take a look at those.
All right, so the first thing, it's very important to understand some of the terminology. So every time we talk about attack surface, vector, and attack paths, so think about that as attack surface as all the angles of attack, either of a system or an environment. An attack vector, the means of how a threat actor can actually compromise a system or the environment itself. And then the attack path would be the combination of all these attack vectors, chaining all these techniques, then they can use to achieve an objective. So when we talk about the AWS attack surface, the first thing that comes to mind is all the services available, right, that a customer can use. But then you're going to start thinking about what it is that you can do with some of these services, right? For example, there are going to be some misconfigurations that could be abused by threat actors on policies. There could be some, for example, non-authentication on these API gateways, or maybe have some misconfigured API endpoints, and also policies, permissions attached to these services. We also have, for example, things such as Lambda functions, computation, serverless computation that you can use. If the input is not validated, you can pretty much abuse that Lambda function. And if you have permissions to modify the runtime, you can then inject your own code and simply use that resource from an organization to do whatever you want, right? Programmatically, of course. And then at the end, something such as a database, right? SQL, non-SQL injections, right? Known stuff like web-based attacks as well. But also we can see permissions that are being abused on those services. And that's the common topic on every single service. And that's what we want to focus on, that specific attack vector, the misconfiguration of permissions that are defined through AWS Identity and Access Management. So what is AWS IAM? And this is going to be, I hope it's a 101 thing. And after 6 slides, you're like, this is not 101 anymore, because it's very complex, but we're trying to keep it very simple. And then it's your job to go back to your organization or go back home and try to go deeper into this area. When we talk about AWS, it's pretty much what is going to manage the access to AWS resources. And this allows things such as multi-factor authentication on specific IAM users. You can actually define federations, so you can have users externally accessing resources into your AWS organization by impersonating what is called a role, for example, or by using a role in AWS. But the main concept is we're trying to define who can actually access what with specific permissions. And when we talk about the who, that's what we're trying to manage the identity. We're trying to manage the permissions, the access that are going to be allowed for this identity or actions to perform against the resources. And we can also manage the permissions of the resources as well directly. So we can do it at the identity layer and at the resource layer as well. That's the concept basics of AWS IAM. And how it works, you can actually go to this link and you can see the structure behind it or some of the concepts. When I read this, I did not understand what was going on with what do you mean with authorization, policies, effect, allow, resources, all the way to actions and services. It was too much. So our goal is to go through some of these concepts. And at the end of the day, you can actually understand this so that you can then move over to the, I would say, how you can abuse some of these services. And that's pretty much what, in my opinion, based on my experience, what an offensive security researcher would do and what a defensive security researcher would do. In general, any researcher should be doing that. You should understand the technology before you try to go crazy and trying to run a few commands that you found in a report or that you found online just by watching a few videos. I highly recommend to understand the technology first. And you can get into a couple of rabbit holes, so that's true, especially if you go into the Windows side of things on-prem, right? The cloud is a little bit, in my opinion, because of based on most of the APIs, it's pretty easy to understand some of the concepts, but it's still you start getting into some of those services that sometimes it just doesn't make sense. But I highly recommend to do that first, understand the technology so that you can feel comfortable going through the other scenarios. So let's start with the basics. An AWS account is pretty much a what is called a resource container that creates a security boundaries for the resources or services that an organization would use. This can be also managed, for example, by an AWS organization. And you can also have the same concept as Active Directory, like organizational units. So you can pretty much start organizing your accounts in a more efficient or better way when your environment is a little bit more complex. Then we have the concept of users, and users are created within an AWS account. And if you want to define access for a user to access a management console, like AWS management console, you define a password, and that's considered a long-term credential. Or if you want to do it programmatically, you're using what is called an AWS access key with a secret key, right? So that's important to understand because adversaries can abuse both, can abuse the usage of a password and can also abuse the access key. So they can actually do or perform actions in a programmatic way. Then we have the concept of AWS groups, which is pretty much grouping users. And the reason why you would do that is because then you can apply policies to all the users that are inside of this group, right? And policies meaning you assign permissions to this. And then at the same time, we have the concept of roles. And this is the one that is very interesting because as a Spanish speaker, roles doesn't make sense to me as an identity. It just does not. Why don't you just call it a managed identity? Why do you call it roles? So it just didn't make sense to me, so I had to understand exactly what it was. Who comes from the Azure cloud side of things? All right, we have 4 or 5 people. Wow, okay. There's a lot more people in here, so 5 is not good. So for those that come from the Azure side, think about a role as a user assigned managed identity. It's a similar concept, which you can apply permissions to this identity, okay? But then you can also allow a resource or a service to assume that identity. So similar to Azure, you create a user assigned managed identity, and then you say this identity can access X, Y, and Z. Let me attach that to a service, an Azure function, for example, right? So in this case, you can attach it to an EC2 instance, to an AWS Lambda function, etc. So that's the concept of a role. And we're going to explain a little bit how this can be abused and how exactly this actually works. Now, how do we manage the access between the resources and the identities, right? That's the main question. And there is the concept of a policy. And once again, we want to make sure that you understand the terminology, the policies. Policies will define the permissions that, once again, or the actions that an identity can perform against a resource. Or you can also say this resource can only be accessed or by defining a policy by these specific users, okay? And something that is very interesting is that if you apply a policy to an identity, it's considered an identity-based policy. And if you attach it to a resource, that's considered a resource-based policy. There are different types of policies as well. There is something called the AWS managed policies, and those are policies that are managed and created by AWS. And those are policies that you cannot change. And those are policies that you can use across AWS accounts because it's managed by AWS. And you have the concept of customer managed policies, policies created within an organization or an AWS account, actually, AWS account. And those can be applied to identities, to users, to groups, to roles, for example. And then there's the concept of inline policies. Remember that, managed and inline, something that Ashwin will talk about in a little bit. Inline are policies that are embedded into the identity itself. It creates this restricted one-to-one relationship. And when you delete that specific identity, the policy also gets deleted. So let's apply these basic concepts now and understand how a user would access an S3 bucket. And for those that are new to AWS, S3 bucket, an S3, it's a storage service. A bucket would be where you store files, right, in the cloud. So the first thing that you can do from an identity-based perspective, what actions can be done on which buckets? So one identity to multiple buckets, right? You define a policy which would allow you to perform actions against this object. In this case, getting objects, getting the files in the bucket. And then you attach that policy to the identity, the user. And that's how a user will access a resource. Simple, right? It's gonna get a little complicated in a bit, but that's just the basics. So the other scenario would be, all right, so that was identity-based, resource-based. Who can do what actions on this bucket? You see the difference right there? Just make sure that you keep that in mind because that would define how you will implement your policies. We create a policy and then we attach it to the resource. And in this case, as you can see in the image, and for those that have the PDF open, we are introducing the concept of principles. And in the principle is where you can define who can actually access this resource. So that's very important because if you keep a wildcard like that, you're saying anyone, any identity can actually access this. And the beauty of this resource-based policy is that you can also define specific users for specific accounts, for example, that can access this object. So this is super helpful when you're trying to do other accounts, other identities that exist in other accounts. So it opens the door to those type of scenarios. And that's what is very important to understand this because when you define your policy, you got to make sure that you pay attention to those principles. So a threat actor would then try to look for those policies where principles are very permissive or just pretty open, and anyone will be able to access that resource, right? So that's kind of like the concepts that need to be understood. Let's think about this other scenario. What if you want an application that is running inside of a service or an instance, in this case of an EC2 instance, and you want to provide access to that application to access an S3 bucket, right? This is the basic approach, and I would say that not recommended approach, but I'm not gonna deny, I've done it before in my lab just to test it, and then when I read that it wasn't best practices, I just felt terrible. And I had to learn a new way to do it, or the best practices to do it. So the first thing that you do is you create a policy, define permissions, right, to be able to access a resource. You can attach that policy to yourself or to a user. You SSH with that user to the instance that is running inside, right, of the EC2 service. And that you can use your credentials, your programmatic credentials, or credentials in general. Those are considered long-term credentials because are coming from your own identity or from a user, a password, right? You will have to manage these credentials yourself to rotate them, change them, right? So then an application can actually take these credentials and then be able to access the S3 bucket, right? So that's the basic approach, but not the most recommended because of the long-term, right, credentials being exposed on an instance. The best approach is to use an IAM role, or the best practices. Not best approach, best practices, yeah. And then we define the same thing. We define a policy, then we have a role, we attach the policy to the role, and then we apply this concept of passing the role, which we're going to explain in a little bit. And then you can provide these temporary credentials so that the instance can assume this role, which means that it's assuming permissions that were passed through the role, and then you can access this S3 bucket, right? So now we're getting into this concept of assuming permissions from an AWS IAM role, and this could be a little bit dangerous if the role is not defined properly, or if the user that is passing the role is not defined properly, which we're going to explain a little bit, which takes us to passing the role right here. So when we talk about passing the role, this is also very interesting because I was very confused at the beginning. Every time you talk about AWS, actions that you can take are technically APIs that you can run against resources, and you can track all these APIs in something called CloudTrail logs, right? And you can identify what people are doing. I thought the pass the role was an API because I was thinking if I'm taking this role and I'm just passing it to an instance, that should be an API, right? That's the way how it should work. But it is not. It is not an API call. It's actually a permission. So if you have the pass role permission as an identity, you can actually create, let's say following the previous example, you can create an EC2 instance and be able to attach this role. But that's not an API, which I'm going to explain what that actually means. So the recipe for passing the role is to define a trust policy that allows a service to assume the role. So in here, we're pretty much simply saying, we want an EC2 instance to assume this role that I'm about to create or that I'm defining right now. Then you attach that to an existing role or to a new role. You can create a new role in AWS and say, let's attach this trust policy. This role is going to be used to be assumed by a service, EC2 instance. Then you say, let's define what it is that this role can actually do. So in this case, you say, I want this role to be able to access an S3 bucket, right? The first one is to define who can assume the role. Second one is, what can I do with that role? And that's when you start thinking two services now kind of like in the picture, the EC2 instance and the S3 bucket. You attach that policy to the role. But then you need another policy, which would allow an identity such as a user to actually use this role with these policies attached in a way that can be passed to to an instance. So in this case, the user needs to be able to have a policy that defines the permission of pass role, and also the permissions that the user needs in order to perform an action that would allow him to pass the role, which would be, for example, creating an instance. Because you can pass a role, you can assign a role to a service when you create an instance in that service, and that's how you actually are able to pass that role to the new instance, for example. So the user needs to have the permissions to do that besides the pass role, okay? And as you can see at the bottom, we have the concept of resource. Resource is where you define what roles can the user actually pass. So we define the EC2 role trust policy first, saying that the EC2 instance can assume this role. But the user itself also needs to have permissions to be able to say, I'm creating an instance and I want to pass the role as the instance is being created, but I also need to have permissions to access that role. So you see how it starts getting a little weird and complex? So, but this is kind of like the recipe that you have to think about, because from here, you can then start thinking about potential attack vectors. Now, once the user has the permissions to pass the role, what happens is, as I explained a couple of seconds ago, the user is going to create an instance. That's one way to do it, to pass a role. And because the instance is being created, you can actually see that a role is being passed to this new instance. As mentioned before, temporary credentials are available now in the instance. Instance assumes the role, and then instance will access S3 buckets. But the left part is very interesting, because what if we define a wildcard in the resource? What does that mean? So that means that we can actually pass any role to a service. And in this case, the role that we defined first was just the basic role to access an S3 bucket and all the stuff. But you can actually pass a role, for example, that has a managed policy that would allow you to have admin access to, just to use that role to say you can do anything on any other resource. So now a user can create a service, an instance, and then it will be able to elevate privileges and have these admin access permissions that are being passed through a role. And now that's how a low privilege user, for example, will be able to take advantage of that specific configuration that allows a user to be able to use other roles in the organization. So that's, once again, very interesting how we get to this point, because there's a lot that could be done when it comes down to IAM policies, but passing the role, assuming a role, creating policies, modifying policies is what we have seen a lot of the techniques that are being abused by threat actors. So understanding those concepts would allow you now to move to the next stage, where Ashwin is going to talk about some of those techniques. And I hope that this now makes more sense, because now you understand that there is the concept of identities performing requests. Those requests are being passed in a form of a policy. Policy is going to be analyzed in order to see if you're authorized to perform an action or access a resource. And then what you can do with those resources are the APIs that are exposed, like the actions exposed by those services. And the resources could be S3 buckets, EC2 instances, etc. So I hope that these kind of give you an idea of AWS IAM. And I will pass it to Ashwin, who will dive into the techniques and the attack.
Yeah, so this was not definitely 101 that was promised earlier on the slide. Yeah, you may want to go back and probably recap a section on the pass role, which is pretty crucial. But all of these information sets a good foundation for the things that we are going to talk forward, right? So now let's talk about the attack and defend, right? So the privilege escalation is a common tactic to take advantage of the IAM misconfiguration. So far, like researchers have published like 31 different IAM privilege escalation techniques, right? If we summarize those 31 techniques, as a defender, you can immediately start sweating like you have to have a detections to cover all of those 31 techniques. So let's try to understand how it summarizes. So all of those 31 techniques get distributed into 8 major AWS services. We will see the visualizations of which those services are and what actions that maps to those services, right? But the broader trend in that is like 50% of those techniques are for AWS IAM, which is kind of expected because IAM provides like multiple APIs to make changes on the identities, right? So you can basically abuse that in different ways. And then it's also easier to develop like atomic detections on the IAM because it's a single event and it provides a lot of context on which you can write detection. Now the problematic area, and again, like the pass role things that Roberto covered earlier, are the 30% techniques that involves abusing password. So we'll take a look at the some of the detection challenges that we'll encounter and how do we get past that those techniques. The presentation in this presentation, we are also going to take an example of one basic scenario, which is very straightforward, like a create policy version, and one end-to-end attack scenario where we can go from initial access to privilege escalation and some persistence. So these are the 8 different AWS services which has the 31 techniques are distributed across. And then if you start mapping the API actions associated with those things, you can notice here again, like the point that I was highlighting earlier was the API actions. The more API actions are associated with IAM, right? The distinguishing part that I want to highlight here is like the IAM related APIs are atomic in nature, right? So you can develop detection, straightforward detection on those things, such as, let's say, create access key, right? So the behavior that we want to alert on is like, if somebody is creating access key for some other identity, unless he's an admin, there's no reason for him to create passwords for other users, right? So you can develop a straightforward detections on that particular API. But some of the other APIs associated with different services do not generally indicate suspicious activity, right? So let's say create notebook instance, where someone is just creating a notebook instance, that does not indicate any malicious activity. So we have to get into the weeds of like what is really malicious with that API activity, and then correlate multiple events in order to develop like an effective detection for those things.
Yes, so the important thing, once again, right, it's just that if you look into some of those APIs for some of those services on the right, that is not an IAM service, that would just look normal in your organization, right? So understanding how those could be somehow correlated, or at least you can do some, hunting engagements on policies and also services where some of those policies could be used. It's pretty much what would add the context that you need to identify a potential privilege escalation technique, right? So it's very important, because we don't want to say monitor those APIs, and if you see them, they are malicious. It's not, right? There needs to be some context attached with those APIs, such as the IAM context that happened before those APIs get executed, right?
Yep. Yeah. So now let's take a look at the first and very basic version of the privilege escalation. The first technique is like create policy version. So let's understand from the attacker point of view. So in this case, the attacker will generally start with compromising a low privilege user. In this case, we are assuming that the user has some kind of misconfiguration. So that user has a policy attached, which is where the IAM create policy version is the action is given to that user as an embedded policy, and then for all resources. So the way this is the first step that I described earlier. So user has this manage policy attached. So once the attacker compromises low privilege user, so what he can do is he can, due to the user has a permission to create a new policy version, he can create a new policy version, specify an inline policy, which is basically **, like which is like full admin policy. And then while creating a new policy version, he can also set a flag, which is like set as default as true. That means that immediately when the policy version is created, it is in effect. So ultimately allowing the attacker to become a full admin, right? So this kind of explains the scenario, like how the privileges have been applied. So let's take a look at the first demo of the presentation. So as we mentioned earlier, like we have a
so one thing also there is, if you went to the link initially in the first slide of the talk, that takes you to a GitHub repo, and in that GitHub repo also you can see the notebooks, just in case if you want to follow along and you feel that it's too little, right? Because a notebook, if you're trying to explain things, it might not be sometimes the best for a presentation, but Yeah, just keep an eye on those notebooks. Also, they're in the repo.
Yep. So if the notebook is itself is new for you, so it's basically kind of another tool set to capture your knowledge base along with the executable code in a single place, right? So we are going to see the value of the notebook in this presentation by providing all the things into a picture. Right? So the notebook has a table of contents where we have like a major sections on like the first one will be starting with the cloud formation template deployment, so which will create like vulnerable user in order to like you can simulate the attack by using that identity. And then once we deploy the template, you can execute the simulation instructions which will perform that attack, and then we can start extracting that data set from CloudTrail logs, and then also analyze the data set that has been created. And then at the end, you can destroy those resources. So the notebook is pretty automated. There is a zero action needed on your end in order to execute this. So notebook has like helpful notes. You can just scroll through and images and those things to understand like what infrastructures that we are deploying, right? So the first thing is like you can just specify some arguments that can be templated throughout the notebook. The good thing is like all of the shell commands. So all of the shell commands have been assigned to a variable and then pass on to the next command. So there's not any copy paste or like manual things that you have to do as part of this.
And the reason why, so Ashwin is showing that part is because, as we mentioned before, our idea is not just to say, run these 3 commands in your AWS environment. Our goal is to define a notebook that would show you how you can deploy a lab infrastructure, how you can deploy a user that would allow you to run the simulation. And then once you get to the detection side, you can pull all the logs that were created by the same user. So it kind of walks you through the whole process. So if you want to do a training in-house, you can use this format. If you want to test it at home, you can do it, consulting, anything. So we just wanted to provide something that would walk you through the whole thing in one place. And all that is by using Python and some APIs. So
yeah, so basically you don't have to go to the AWS console or any other places. The notebook is kind of like a central pane of glass to do these all the activities. So for each of the notebook, what we have done is like as a prerequisite, we will create a new identity that will be used to deploy this template. The reason for this is basically you can use that identity to filter the logs so that you can only extract the activities that happen as part of this scenario. So let's quickly move down once we kind of move past on the deployment template. Let's start the simulation instructions, right? So once we deploy the infrastructures, the cloud formation template has also an output, which will output the user identities, the access keys associated with that, which you can specify as a new profile in the AWS CLI. And then this is the local file on the file system, which kind of specifies the full admin policy that we talked earlier. Is a star, right? And this is a single command which will basically perform this attack, which will create a new policy version, right? Specify the policy document as the JSON file that we passed earlier, and then use the flag set as default, which will basically create a new version here, as you can see, v2, and then it's also default version is set as true, right? So no fancy tools, it's just plain AWS CLI. It's just how the misconfiguration has been abused through a single command, right? So the next part, and which is again the primary focus for this talk, is how do we extract that data set and then start analyzing for detections and hunting queries. So the data set extraction is pretty much is like hooked into your CloudTrail and then basically filter those identities that we used to deploy the template or to perform the attack, and then just export those as a JSON. So again, you can move past to the Python complex code. You may have like a tool sets like log management tools and other things to explore the data set. But the point that we are highlighting is these are the events that were generated when you actually deployed the infrastructure, right? So this is also another area that you can basically think of it when somebody deploys a vulnerable infrastructures. You can treat it as a terminologies that you can use and then codify into when someone in your organizations accidentally deploys such infrastructure.
Good question. Are you using pandas there too?
Yes.
Okay.
Yep.
So for those, right, just also can practice a little bit of your pandas skills, right? Just another library to be able to process data in a tabular format. And it's pretty much what you would use also, besides your regular analytics engine where you type your, let's say, either a KQL query or Elastic query or a Splunk query, but you can also process data with Python and pandas, right? So also another thing that we use, so we're just trying to show a little bit of those like concepts and how we go from logs from CloudTrail to a pandas data frame, right? Something that might be simple, but you know, for those that didn't know, that's something you can do with a notebook as well. Yep.
Yeah, and then since we are basically sharing the data set itself, you can also ingest that into your log management platform to test your detections and all. The next thing is the actual attack that we perform, which is the create policy version, right? So this is the one API event that we saw earlier, which is the create policy version. And then these has like multiple attributes that you can basically provide the context that a defender can use to basically codify into a rule that you can alert for SOC, right? So the key thing is here, the event name is the create policy version. And then in the request parameters, you can access the policy document, which will actually show the inline policy that was passed as JSON format, right? So now, if you are able to pass out those policy documents, you can basically write certain logics where you can start to look for the wildcard characters with allow, broad allow. And then the another thing that we talked about earlier is the flag, the set as default. So the HTTP parameter also has the separate field, which you can basically access and then look for the value as well, right? So all the context is available in the single event, right? Which makes defender's job a lot more easier. But we are going to take a look at some of the complex scenarios and then how does it look. And then lastly, just like pinning up the resources in one single. So let's move back, right? Right, so just to summarize, we can start understanding like how do we detect the creation of high privilege policy. So you can basically find out these create policy events with certain parameters and then convert it into a detection. And then the actual technique, which has the create policy version single API event, on which you can basically add this additional context as a kind of detection. Right. So let's think about like, so now how an individual technique can be fit into a end-to-end attack scenario, right? So if you are again new to the cloud world, it will help you like how does the end-to-end cloud attack scenario looks like, right? So in this case, we are hypothesizing like there's a public bucket with SSH keys stored. So this can happen many times accidentally, like developer just leave the SSH keys for their EC2 instance. And then since it's exposed publicly, the threat actor can basically scan those public buckets and then gain access to the SSH keys, and then use those SSH keys to log into EC2 instance via some default accounts or any of the identities that he knows from the organization. So now the next step the attacker can perform is the stealing the AWS credentials. Now, if you're thinking of a developer boxes, you can immediately think of like he will be using, or like he or she will be using AWS CLI. Once it's configured AWS CLI, the access credentials are stored into the local file system called credentials.aws credentials, or it can also be stored into the environment variable. So once the threat actor gains access to the EC2 instance, they can read those things and then basically extract and then use those further to log into AWS CLI. So once it's logged into the AWS CLI, the threat actor can start performing some discovery commands to understand like what privileges that identity has. Once the actor understands that it's a low privilege user, he can start picking up one of the techniques that are published out there out of 31. He has a choice to pick, and then probably become a full admin. And then lastly, the threat actor can also add like persistent backdoor, so that once if he ever lose access to the admin role, he can gain back the permission through this persistent backdoor. Right? So let's quickly go to the notebook, the second notebook, to understand how does the arrow looks like. Again, I'll scroll fast, which has like similar sections starting from CloudFormation template deployment, then configuring users, all those things. So let's take a look at the simulation instruction, right? So here in this case, we did not talk about what is the privilege escalation techniques or the persistence techniques that threat actor may be using. So this simulations command can give you an idea. So once the threat actors assume that identity which was stolen and then use that to log into the AWS CLI console, he can start performing some discovery command like get caller identity, list user, list access keys to see like what privileges threat actor has. Now, the threat actors can start assuming certain roles and then gain some additional privileges. The threat actor can also start listing out certain buckets, understanding if there are any sensitive data is there. Now, so we talked about the S3 bucket is public. So without accessing, so in fact, this is the first step the threat actor can perform is just like sending a curl request to an open bucket. The threat actor does not have to authenticate in order to download the SSH, right? And then this is the privilege escalation techniques, which would basically abuse the update assume role policy. So the threat actor can become a privileged identity after supplying the full admin policy, then updating the underlying. For persistence method, this is something that we have also seen in the recent blogs by researcher companies. Is like the threat actor can start creating some commonly used usernames such as backup or default usernames, and then the threat actor can basically supply the user policy, which will basically again an example can be like again admin policy or any of the other policies to become a full admin. Right. So this data set is again we're kind of working on exposing it into a public GitHub, but then you can go back and.
A quick question, Ashwin. Which policy was assumed by the threat actor? So was that like an admin access role that was available, and then the threat actor assumes a role, right?
So the first stage is like the user is kind of assuming a certain role to basically perform certain activities, which is kind of there existing, and then he can basically abuse the privilege escalation techniques, which is like update assume role policy to supply an inline admin policy and then become.
So the role had the permissions to allow the threat actor later to apply a new policy with elevator privileges.
Yep.
Pretty much. Okay. Sorry, we were talking about some of these scenarios, and then we have all these things that we were trying to put together. So it's good to clarify because I wasn't as clear into which policy and how the policy was being created. What allowed the user to create that policy is very important. So it's interesting how a threat actor was able to assume a role that had permissions to then, update the policy or apply a new policy that would allow the threat actor to have access to any resource or any, service out there, right? So that path, I think it's interesting to.
Yeah. So similar to like the first scenario that we talked, where the threat actor had a permission to create a new policy version. In this case, the threat actor had a permission to update a assume role policy. So what the threat actor ended up doing is like updated an existing policy and then supplied an inline policy to become a full admin.
Interesting. Thank you. Good.
And then, so yeah, let's talk about the detection challenges, like as a defender, how your job is difficult. So the first scenario that we talked, again, I'm kind of repeating myself. Some of the events are straightforward and then provide a lot of context in order to basically look for malicious activities. But then the attribution challenges is very real in the cloud world, right? So the IAM 101 that you saw earlier in the first 15-20 minutes, right? So as you can see, like there are different parts of identity impersonation, right? So there are many things that can happen when you see an actual API call, let's say list of buckets, right, with certain role. That role can be assumed by other role, and then that role can be assumed by multiple users. Now, the user can also be a part of the group, and then a policy can attach to those rules, to those groups, and those policies can change over time. So you can tend to see like there are like multiple events that you need to correlate in order to put those contexts into picture, and then in order to effectively develop a detection. Another challenge that we'll often run into is like we talked about earlier about parsing the policy document and then using that for detection purposes. Many of the organization policies are not straightforward. It can have like multiple conditions. So, and then the organization can also use something called permission boundaries, where the organization can set up a permission boundary to restrict the permission that will be accessed by an user. So even though you are allowed to create a full admin policy, but if you, as long as you attach a permission boundary, you'll not you'll be restricted from your policies. So evaluation of those customer managed policy or inline policy is very complex at runtime. Right? So the way that we have seen the organizations are doing is that there are open source tools exist, which will kind of use or like which will kind of hook into your AWS infrastructures, get the export of those identities, do an offline analysis, do some Neo4j graph analysis, and then provide risky path permissions in order to basically identify those attack paths. But as a defender, those information is not readily available in order to correlate and then set up a detection. There are also like other challenges. There are lack of telemetry for pass-role actions, which makes difficult for those things. And then the IAM access analyzer, which is by design supposed to monitor these things. It's not enabled by default. There's like additional steps are required. And then the ingestion of IAM access analyzer findings is also not set up by default. So you have to set up per region and then get those things for context for analysis. So we definitely don't want to keep you stranded and then still provide some defensive guidance. So we talked about 31 techniques. The way that we can approach for detecting those techniques is something splitting up into detection and hunting queries. So some of the detections that you can start thinking of, like creation of high privilege policies. So there can be multiple ways through which the user can create a high privilege policy to make sure that you look for those API actions, pass out certain fields, and then in order to evaluate that it's a high privilege policy. So creation of high policy itself is not an actual indication of something bad is happening. It just created. So what you should start looking for is like once that policy is attached to an actual resource and then that resource has been started, or if that the policy is being attached to multiple identities, so you can start expanding your blast radius to cover those additional identities. And then some of these generic hunting queries that we talked about is like, which is kind of like a noisy behavior that you can start looking for. The purpose of this is just to provide a signal that can be correlated by your other alerts. All right, so this is probably the last slide that we want to summarize our defensive guidance. The way that we can summarize those techniques into three major categories. So the first one is the understanding the policy scope. So if you properly understand the policy scope and then evaluate that if it's a high privilege one, then you can start developing that into a generic detection with multiple ways to detect those. So again, for policy, you should make sure that you cover for both manage and inline policy. Managed policy is very straightforward. The built-in policy AWS has generally admin keyword in the ARN, so you can start look for those things. For inline policy, you have to start parsing out the policy document. Some of the overly permissive permissions examples that we have highlighted here is the star.star, which is pretty common. Then assume role for all roles, which we've seen in the past role scenarios. And then also like some of the key services such as like KMS or secret manager, so that you have an extra eye, like who is accessing your secrets and how broad that access is given. Now, the next category is basically the policy relationships. So now, once you identify the policy is a high privilege one, let's start mapping those where that policy is getting attached to multiple identities. And then if that identity is further attached to resources and all those things. So you have to start tracking the whole life cycle of that privileged identities and then just not leave it at the policy creations. And then lastly, which is basically going to be like high priority alert for your SOC, is basically once that policy is created and attached to the additional identities, when it is actually started using, that's when then probably some of the malicious stuff can start happening. So make sure that you monitor these resources when they are attached with the privileged role.
Question: when the API calls are used by a service that has a policy attached, right, and it's assuming a role, you do have the event of STS assume role,
right,
which would allow you to know that there was a policy that was assumed by the service. Yep. It executes actions.
Yep.
So that's important once again, because just the fact that an API is being called, it's just necessarily, once again, is not malicious. So I don't want you to go back and be like, oh, this is malicious, yep, right? But just add that additional context. So the key word in here was policy lifecycle, understanding what it is that the policy is allowing to do, what it is, how the policy is now being related to other services, other resources, and then how that service is actually assuming some of those roles in order to perform the actions. Because as you know, there is over 30 or probably even more APIs that are being used to abuse these privilege escalation techniques. So you can either say we have 31 ways to detect this, or you try to kind of map the behavior a little bit that is more related to the policy lifecycle is what the kind of key idea in here.
Yep. And then just add on to the additional points, like you may have like additional events like such as STS assume role, or you can also start understanding what is the user identity associated with each API. So when it's assume role identity, it will clearly indicate in the ARN that it's the assume role identity.
Right.
Yep.
All right. So this is I would say the last two slides, which are just simply showing some of the reference. Thank you to all the companies and also people that were behind some of the blogs that we were able to go through and try to add some context to the things that we were trying to accomplish. All those resources are also in the GitHub repo. And as we mentioned before, what we're trying to share with you is Jupyter Notebooks with the whole end-to-end kind of scenario, deployment infrastructure, the simulation and detection. We're actually also providing a couple of the security data sets that were generated after running some of these attacks. So rather than going through the full simulation, you can probably just ingest that data and either learn or get familiarized with what data look like, or you can potentially trigger some of the alerts internally in your environment. And at the end, of course, research notes and some of the stuff that it's important to probably go a little bit deeper if you want to understand this research a little bit better.